Hi everyone! Get ready. Today we're learning about limits and derivatives, two powerful tools that help us describe motion, change, and so much more. By the end of today's lesson, you should be able to state the limit of a function and the basic properties of limits. A limit tells us what number f of x is getting close to when x gets close to a value a. We do not need x to be exactly a. If a function f of x approaches a number L as x approaches a, then we say the limit of f of x as x approaches a is L and is written as this. For the function f of x equals x squared plus 1, when x gets closer to 0, f of x gets closer to 1 from both sides. The table clearly shows the values moving closer and closer to 1 as x approaches 0 from left and right. We use the substitution method by directly replacing x with the number it is approaching. If we get a normal value, that is the limit. But if we get 0 over 0, substitution does not work, and we need another method. For this example, you directly replace x with 3, and you will get the answer 1/2. Same goes for this second example. Just replace x with 2 to get the answer 5/3. Now that we understand what a limit is, we can learn some basic properties of limits. These are simple rules that help us find limits more easily when we work with constants, addition, subtraction, multiplication, or division. Learning these properties will make solving limits faster and less confusing. The first properties is the limit of a constant function is just the constant itself, no matter what x approaches. So, for the example, the limit of the constant 5 as x approaches 3 is just 5. The second properties is the limit of x as x approaches a is a, because the function just follows the value of x. So, the example, the limit of x as x approaches 2 is 2. The third properties is the limit of x to the power of n, as x approaches a is a to the power of n. For example, the limit of x squared as x approaches 4 is 16, because we replace x with 4. The limit of a sum or difference of two functions is just the sum or difference of their individual limits. This lets us handle each part separately, which is much easier. For example, the limit of 3x squared minus x as x approaches 4 can be found separately. Replace x with 4, and you will get 44. The limit of a product of two functions is the product of their individual limits. Find each limit first, then multiply them. For example, the limit of x cubed multiplied by x squared minus 3, as x approaches to 2, can be found separately. Replace x with 2, and the answer is 8. When a constant multiplies a function, we can take the constant out and just multiply it by the limit of the function. For example, the limit of 5x as x approaches 4. Take the constant 5 out, find the limit of x, which is 4, then multiply to get 20. The limit of a division of two functions, f of x and g of x, is the limit of f of x divided by the limit of g of x, as long as the denominator, g of x, is not 0. For the example, the limit of x squared divided by x plus 1 as x approaches to 3 can be found by dividing limit of x squared by limit of x plus 1. Replace x with 3, and the answer is 9 divided by 4. End of lesson evaluation. Please answer the question and kindly submit your responses using the attendance QR code provided. Thank you for your attention. Please make sure to read the materials before our next lesson. Have a nice day.